Hello! So my name is Kaylee Isom and I am a student at St. Louis University studying elementary education. And today I wanted to show you a quick at-home STEM activity. So the goal of this activity is to both design and create two different structures, make them different, and test out which one beats the other in stability, design, and strength. So for this activity, you're going to need some materials, but they should all be things that you could theoretically find in your house. I used Junior Mints and spaghetti because that's what I had laying around. I didn't obviously want to go out to the store, but you can use tape and popsicle sticks or straws and marshmallows, anything that is going to be able to provide structural support and adhere together. So the Junior Mints were sort of to adhere things, and then these were almost like our structural beams, if you will. So I designed two different structures and I tested them on these components, stability, design, and strength, and I'm about to show you what I did. So to sort of demonstrate how I made these, I basically took longer spaghetti strips and these little Junior Mints, and I would break off the spaghetti into whatever size I needed. I'd lay down the Junior Mint and I would just poke it into the spaghetti. Then you could take another piece of spaghetti or whatever you're using and poke that in as well. So now we've got this little structure that holds pretty nicely, and you could just keep adding these little adherence points and your beams until you make a full structure. So let me show you the design that I am planning to make. So I went ahead and I made two little designs here. My first design that I'm going to build is almost like a pyramid shape. It's got a square base and it has 4 triangles, all of equal area, coming up to 1 point of weight. And so then again, that's 1 square, 4 triangles. And the other design that I'm going to test out is a cube. And that involves 6 squares, all of the same area. They all have the same height and width, coming together just at the corners at 90-degree angles. So let's go ahead and test out these structures and see which one is stronger. So this is one of the structures that I was able to make. As you can see, I did a square as a base, and then I did 4 triangles sort of coming up to a pyramid shape. So I'm going to go ahead and rate this one on its strength, stability, and overall appearance. So this is my other shape. It's a cube. It's got a square on top, a square on bottom, and then 4 squares all around. They're just about even sizes to form a little cube here. And I'm going to go ahead and rate this one as well on its structure, strength, and design. And we will see which one was more sturdy. All right, so now we've got the really fun part, and that is to judge which shape won. And I'm going to be judging all of these categories on a 1 through 5 basis, 1 being the worst and 5 being the best, on stability, design, and strength. So stability would be the structure's ability to withstand an outside force, maybe like wind. Design is just the overall aesthetics of the structure. And then strength would be the structure's ability to handle a load coming from the top. So let's get started. So for the pyramid structure, I would say the stability was about a 3, because it wasn't perfect, but it was standing upright the whole time, even though it was sort of leaning from one side to the other. For structure, or for design, I would say I'm going to give it a 2, just because I didn't cut the spaghetti at exactly the same lengths, so it was leaning toward one side, which looked a little bit wonky. For strength, I'm going to give that one a 4, because when we have 4 points coming to one little point, it kind of takes the strength of all 4 of those sides and really maximizes it. So I'm going to give that a 4. On the cube, For stability, I'm gonna give it a 2 because the cube started falling over, it wasn't very sound. If a big gust of wind came, it could really knock it over and that wouldn't be good. For design, I'm going to give it a 3 because I do think it looked pretty nice. It was a little bit uneven, but overall it was sound, so right there in the middle at a 3. And then for strength, I'm gonna give it a 2 because if I put something in the middle of my cube on top, it's kind of just being supported by the outside area. There's no central point like there was in the pyramid to really hold the object's weight. So I'm gonna go ahead and actually average the scores for these. Now to make an average, you wanna add up all of the parts and then divide it by the amount of parts you're adding up. So this would be 3 plus 2 plus 4, which we know equals 9. And then there's 3 parts we're adding up, so we're gonna divide it by 3, and you get an average of 3. For this one, we're gonna add these up too. 2 plus 3 plus 2, and that is gonna equal 7. And if we divided 7 by 3, it's not gonna come out quite as pretty. We'll get something like 2.3 for that average. So that shows us that our pyramid design was the winner for the overall STEM competition. Thank you guys for watching. I had a lot of fun. Again, this is a super easy activity to do at home, and it's really important to do these little STEM activities because they really enhance your critical thinking skills, your problem-solving abilities, and just your overall understanding of science, technology, engineering, and math. So I hope you had a fun time. I know I did, and I hope you have a wonderful summer.